Welcome back, Regents students. I hope the homework went okay yesterday. I just want to remind you a little bit about the procedures. So you're watching these videos, you're taking notes, and then you're taking photos of your notes and loading them into Google Classroom for credit. That's one step every day. The second step is you then complete the homework assignment in the unit plan, which is the first thing in our Google Classroom stream. Complete the homework, answer the questions, take pictures of that, and submit that in Google Classroom as well. So 2 different sets of photos. And then you check your the PowerPoint with the answers, the daily answers. And then after that, if you have any questions, you go into the Google Sheet and tell me what questions you had trouble with. And if you had no questions, then you put an X in the Google Sheet in the column for today's homework. So that's the procedure. Again, just a little reminder. In today's lesson, moving on, we are going to be talking about how to create or how to analyze data with graphs. Graphs are very useful for showing trends, visuals, and also you can calculate the slope of a graph to basically quantify how something is changing. So that's what we're covering today. And I also want to say that as I already mentioned with calculations and putting in all the units, there's a very specific way that you have to show your calculation in the Regents. So we're going to talk about that today, how you show the calculation of a slope, all the steps that you need, very picky in the grading, and also the same with the graph. You have to create a graph and have a lot of different things on the graph, and there's lots of different ways to lose points. So that's all what we're going to be talking about. How to create a graph to get full credit with all the little features that you need, then how to draw a best fit line for linear data, and then how to calculate the slope. After we do that, then you will do the Pi Lab after this video. You'll stop watching this video, then you'll watch the next video, the Pi Lab, and I basically do the lab and you watch the lab with the video, and then I'll assign you data and you'll analyze that data. So best we could do with the situation that we're in. All right, so let's go and begin. So I put some data, kind of prepared the notes a little bit on the board here. So this is the title for today, Graphical Analysis. And let's suppose I just put very briefly what the experiment is. You want to see how eating donuts affects a person's body weight. So you get a particular subject and they're going to eat 5 donuts a day and measure the weight in certain time increments and see, does the person gain weight, stay the same, or lose weight. So we've taken data and we've performed this experiment. I put the data here, and I'll just pause the video at this point so you could copy this data down in your notebook. Okay, so hopefully you have all this jotted down correctly. Now I want to point out some specific things, again, technical things that you need to do to have the full credit. Remember, if you're writing an English paper and your sentences don't have verbs, it may be clear what happened. John to store. Okay, we could say probably John went to the store, right? But without a verb, you're going to lose credit. So there's like what we call a syntax, a grammar, a way you have to show your thoughts in English. And it's not good enough just to give the information. It has to be presented in a certain form. And it's the same thing in science. Notice how I have this data table labeled. I put time here and weeks and weight and pounds. So every column in a data table needs what you're measuring and the units. Now, if you put weeks here, we probably would figure out that it's time, right? And if you put pounds, then that would be enough information. But again, that's not the format. You need what it is that you're measuring and then what the units are that you're measuring it in. The other thing, the left-hand column, right-hand column. it's not an accident that time is here, because what goes on the left is what we call the independent variable. Okay, independent variable. And it's like what it sounds, it's independent. Time doesn't need you to eat any donuts to continue. It just runs by itself. So this is the thing that's independent of all other influences, which isn't true, by the way. There are influences on time, but I'm getting ahead of myself. Okay, this is what we call the dependent variable. Your weight depends on how much time goes by in your experiment. So this is the dependent on the right. The dependent variable, okay? So we've got our trends, and what we're going to do now is plot this. Now, best I could do with the whiteboard, I created a graph like this. You're going to have to do the same in your notebook. In class, there was a nice little stamp I had that you could stamp a little graph grid in your notebook, but you're just going to have to try and draw maybe with a ruler so things are as accurate as they can be. But generally, in a real lab, you wouldn't do that, because by drawing it freehand, a graph is supposed to be showing the trend accurately and precisely. And when you're drawing graph paper freehand, you already lose that precision. So your experiment becomes inaccurate just because you're hand drawing the graph paper. So we're doing this for the notes, but in a real lab, you would need real graph paper. Okay, so what always goes on the bottom axis is the independent variable. So what I do is I put time and then in weeks. And again, don't worry if you can't keep up with me. I'm going to just put this all, and then I'm going to pause the video so you could jot down this stuff later. But right now you could just follow along. So again, the same kind of labeling. What is down here, and then the units that are down here. And what goes on the side axis, or the y-axis, a lot of people like to say, is this variable, the dependent. So what I'm going to do is label it the same way. I'm going to put weight over here, and the unit also. So that same labeling has to be maintained. And one last thing a lot of students forget is a title on a graph, and you lose points for forgetting a title. So I don't know, weight experiment or something like that, I could say. Or maybe donut experiment if you'd like. Or if you wanted to be really precise in your title, you would say weight versus time experiment, but weight experiment is fine. Okay, so now the next thing we have to do is set up our axes. Here's a common mistake students will do. So don't jot this down if you're following along, jotting 0, 2.0. Oh wait, oops, I forgot. So again, this is wrong. 0, 2.0, 4.2. And I'll stop there because that's enough to show why it's wrong. The reason why this is wrong is it's going to stretch and compress the data and distort the trend, because look at this space is 2 weeks and this is 2.2 weeks. Even though it's the same distance, that's not going to create accurate representation of the data. What you have to do is you have to say, okay, look, I'm going to about 16 weeks. And then you figure out an even increment that gets you to about 16 weeks, ignoring the individual points. So 2, I set this up ahead of time for 2 to work. So instead of this being 4.2, I'm going to call it 4, 6, 8, 10, 12, 14, and 16. Hopefully that's on the screen. Okay, yes it is. All right, so it can fit all my data. And then this axis, well, I'm not going to start at 0. Well, I do start at 0, but I'm going to create a break in the axes, which is fine, because there's so much data that if I spread this evenly, all the data would be at the top of the graph like this. So what I'll do is, let's see, if I jump to 140, 150, 160, 170, 180, 190, 200. So that's good. So I'm going to jump to 140 here, and then 160. Now you might be saying, isn't that creating the same problem, that this is 140 for that space and only 20 for that space? Okay, but what you can do is you can create these sort of lines like this, a couple lines. No, whiteboard doesn't work well when you go back over. Okay, so, and that tells the reader that there's an uneven increment there, and that is allowed if you have that symbol. So continuing, oops, no, 150 I meant. 160, 170, 180, 190, and 200. And you could see that I could fit all my data. The lowest is 159, somewhere like here, and then to 195 here, so it'll reasonably fill up my graph. Okay? And now what I'm going to do is go ahead and plot these points. So 0, 195, what I do is I find 0 on the x-axis and 195 on the y-axis. Here's 0 on the x-axis, 195 on the y-axis. So let me make a little space because marker doesn't like to go over itself. Okay, so there's 195. 2 weeks, 188 pounds. So here's 2 weeks. 188 pounds is somewhere around here. So what I do is I go up like this and over like this, and I put a dot like so. At 4.2 weeks, the person was 187 pounds. So 4.2 is like somewhere around here. And 187 is just a little bit lower than the last point. Again, this isn't very accurate because I don't have many grid lines. I don't have any grid lines, but again, we don't have graph paper here, so. And then 5.7 weeks, 182. So here is 5. 5.7 will be kind of close to 6, right around there. And then 182, 180, maybe 182 is like that. So I go up and over, and there is my point right there. Okay. 7.7, 176. So here's 7, and then 7.7 would be right around there. And 176. 175 is right around there. 176 a little bit up. I go over and up and right around there. "10 weeks exactly and 175. So 10 weeks, 175, going up to here, 175. Okay. 12 and a half, 167. Here's 13. 12 and a half is going to be right around there. Okay, so let me put a little mark there. And 167 will be somewhere, I would say, right around there. So I go over to here and plot that point. And then 14.2, 166. 14.2 would be right around here. All right, right around there, a little bit beyond 14. And 166 would be somewhere around here. So, okay, and then finally 15.7 and 159. So here's 15. 15.7 will be somewhere like that. And 159, well, That'd be somewhere around here. So I go over and like that. And so we see a downward trend. It's not perfectly linear, which is fine, okay? Data very seldom goes perfectly in a straight line. So there's a straight line. So what I'm going to do now is pause the video and give you a chance to copy this down to the best of your ability using a ruler. By the way, I also put a ruler in the Google Classroom stream and a protractor in the very first entry in the Google stream with the unit plan. So basically, you could print out that ruler and cut it out. Well, there's a bunch of them there. Cut out which one, looks the best to you. The protractor, by the way, you can resize and it won't change its accuracy. The ruler you can't resize. You have to print it as is. But if you want to make the protractor smaller, it might be easier to use. Shrink it down a little bit, then print it out. And it, like I said, it might be easier. Okay, so let me pause. Go ahead and copy this. Okay, so the next thing you have to do, once you plot, you're going to get graded for this, the spacing of the axes, the title, how accurate your points are, and then the best fit line. This is very important. We do not connect the dots, okay? So a lot of students might go, do like this, like that, like that, like that, and they'll lose credit. Another thing students lose credit for is they'll just draw it freehand with like this and just kind of also lose credit. When we grade it, physics teachers, we actually look down like this to make sure the line is straight, that you drew it with a straight edge. So that's what you're going to do. You're going to take a ruler, put it down, and leave it in one spot where it approximately passes through the center of the trend. Like, for example, this is not a good best fit line because all the points are above the line. This, they're all below the line. No good. You want about half of them to be above, half below. Give or take. It doesn't have to be perfect. But even that rule, this is no good. Okay, we've got 4 points below the line and 4 points above the line, but it's not following the trend. So it's got to follow the trend and have roughly half the points above and below. Now I'm probably going to mess this up because it's hard to do on a whiteboard without the ruler moving. And it's hard to visualize. So I'm going to do my best. Maybe something like that. Let's see. Okay. All right, not bad, okay. And at this point you might be saying, well, how do I know it's the perfect one? You don't. There is no such thing as a perfect best fit line unless you can use a computer or a Texas Instrument calculator to calculate it. Then it does a statistical analysis. But what you're doing is you're just making it the best you can by your eye, okay? And it may take several attempts. So I recommend going back when you're plotted the points, dot these in ink, and then try the best fit line in pencil. So you could erase, try again, erase, and the points will still be there because they're in ink. All right, so give it a shot yourself. I'll pause for a minute. Okay, so then we got all the things here, okay? Next thing we're gonna do is calculate a slope. And the Regents is very picky with that as well. So let's take a look at what you have to have in a slope calculation. Okay. Let's see, did that fit on the screen? Yes, okay. Okay, all physics calculations on the Regents and on our unit tests have to begin with an equation first. And what that means is all symbols, no numbers. Step one, always an equation. And the equation that we're going to be using is slope equals, there's different ways you could write it. You could write the word rise divided by run. Sometimes they say that in math. Or more common in math, they usually do this, change in y over change in x. You could have had change in w for weight over change in t for time. That would work also. So a little bit of flexibility on the formula. But you need something, a math statement with no numbers. You also cannot have units, pounds over weeks as an equation. That doesn't work. It has to be just math symbols. Next thing. You plug in numbers with units. But here's the key. There's a lot of things to know about how to plug in numbers. The first thing, you never use data points. So it's like in your mind, you pretend these don't exist anymore. Don't even look at them. Don't look at your data table. No more. You're looking at the line only because the line is like the average. Just like if I want to know the average height of a Clarkstown student, I don't look at the two players on the basketball team and say, oh, there they are. The average height is 6'5" of a Clarkstown student. No, you don't look at any one point no more than you would look at any one person to get an average of people. You look at the trend, the line. The other thing is, you don't pick 2 points on the line that are close together like this. It's inaccurate for a similar reason that I just mentioned with the two students. You're looking too small. And a lot of times people say, well, but these go right through the grid lines. I like these because, you know, well, it makes it inaccurate. What you want to do is you want to pick a point near the beginning and a point near the end. New data points, or new points, I should say. So let me go like right here. And maybe right, yeah, I could go right here. So I put 2 dots very near the beginning, very near the end, or you could put it right at the beginning and right at the end. That's good too. So then what I do is I do the change in y. Now notice the y starts at about 190, okay? Maybe 189, looks like a little bit below, 189. And I put the unit with it. And then the y here is about 166 maybe. And then the change in x, well, this x point, it's looking like maybe it's, I don't know, 0.8 weeks. Oh, I should do, oh, you know what? I did this backwards. I do final minus initial. 166 minus 189. You always do the final minus the initial to get the proper change. Because the change is negative, right? It went down. So the other way, it would have been a positive change line going up. Okay, the final x value looks like to me it's right around 13 weeks. Maybe I'll abbreviate it, WKS, that's fine. And then this one is about 0.8 weeks. So I have my numbers plugged in with the units, okay? And then I could just get a calculator out and say 166 minus 189 divided by 13. Oops, forgot a parenthesis. And I get negative 1.89. pounds per week. And that's the trend, that throughout this experiment, this person lost about 1.89 pounds every week they were performing this experiment, okay? Eating 5 donuts a day, right? So before I talk about that and interpreting that result, I just want to again point out the multiple things you need to know. An equation, a substitution with units in every number, and then an answer with units. And I just want to reiterate the importance of units. If you did this on a Regents test, and you look at that, before I talk to you about the Regents, I asked, well, what do you think a person who just left that off should get on a question like this when they did all this work? You probably say, well, at least probably like a 9 out of 10. Like this is just like a little tiny mistake. And I would agree with you. I would say you're right. That the person deserves a 9 out of 10. The way the Regents would grade this is a 1 out of 2, a 50% F for that tiny mistake. Horrible, I agree. Horrible, unfair, mean, okay? But again, that's a state requirement of the Regents test. So all these little units have to be in, okay, the numbers. If you have a step in between here, you don't need units. If you have another scratch step here. But the first place you plug in the numbers and the answer, if you leave this off, 1 out of 2, 50% F. You leave the equation off, 1 out of 2, 50% F. So many ways you can lose half credit on a question in the Regents physics. Not nice, okay? But by the end of the year, you'll be doing it, and it'll be no problem because you'll know how mean they are, and it'll be in your mind. Last point I want to make is that, does this mean eating donuts every day, 5 donuts a day, makes you lose weight? Well, there's the larger scientific question of looking at the validity of the experiment. Maybe this person who started this experiment started on the day they joined the military, and they're in boot camp. I've heard about people that carry logs on their shoulder up a hill. They're running at 5 in the morning, 10 miles or whatever, push-ups and all this. And then that happened the same time they began the experiment. You would say, well, eating donuts makes you lose weight. No, it was the boot camp that did it, right? And the donuts are irrelevant because of how hard they were working. So, there are larger scientific questions that you have to think about, a well-designed experiment that makes sense logically and scientifically. But this is the technical way you analyze the data. Data table, graph with all these labels, okay? Oh, I guess I never paused the video for this, but anyways. So labels, and units, title. Points plotted out. Best fit, and axes evenly. Best fit line, okay? And then when you calculate the slope, 2 new points very far apart, and on the line, not data points. No data points in this calculation. And then equation, substitution units, answer units. That's analyzing data with graphs on the Regents. That's it for today's lesson. However, we do have lab today. As I mentioned already, I did the PyLab experiment at school yesterday. So what I want you to do is watch that video of me taking data, and then how do you say, and so you'll see kind of what happened, how it works. Print out the lab sheets, not the instructions, but the analysis sheets. Analyze the data properly with all these techniques. And then when you're done with the lab, take photos of the lab and submit that in the Google Classroom stream. And that'll be your, quote, lab for the day, right? Again, best we could do. All right. Thank you for watching. And I'll see you, well, in a couple minutes for lab. Okay.